I'm going to start reviewing this example. Again, I'm going to do it, you completing this square. I know I can use the completing the square method because the number in front of the x squared, the leading coefficient is 1. There's actually no number there, so it's understood to be 1. And the number in front of the x, so the number that we call the b, is an even number. So let's see if we can solve this problem with the completing the square method. Now, usually when I have a quadratic equation, I want them to have all the terms on one side equaling 0 on the other side. But when we use the completing the square method, we want only the terms with x's on one side, and on the other side, we want any plain number. So, and which is exactly the way this is set up. So in order to complete the square, let's remember, you take half of this number, you divide this number by 2. So 2 divided by 2 is +1. And you multiply that number by itself. So 1 times 1 is 1. In other words, you square that number and you add that number to both sides of the equation. So I'm going to do +1 on the left side and +1 on the right side. So that we end up, this is now the binomial x plus 1 squared. It's easy to remember because the number over here is exactly half of this number. It's the number that you had to find before to get to this number. So this gives you x plus 1 squared. And on the other side, -5 plus 1. Oh, wait, I'm sorry.
Professor, what's the name of this operation?
This is called completing the square.
Okay.
To solve a quadratic equation, completing the square.
Good morning.
Good morning.
Professor,
Yes.
so in all the completing the square, we gotta add +1.
No, you don't always add 1. The number you add is you take the number that's in front of this x. Like, let me just switch. Melissa, I'm gonna make you the host, okay?
Alrighty.
All right, Melissa, I just have to find you. Okay, let me get, because I'm getting, okay, let me find you so I can make you the host. Okay, Melissa, I'm now making you the host, okay?
Okay.
You got it. You're in charge. And I am recording. Okay, so when you're completing the square, let's go through this again. You take the number that's in front of the x. It's what the number that we call the b. And you divide it by 2. If you take that number, you divide by 2, you get 1. The number that you get, you then multiply by itself. You square this number. Now, 1 times 1 happens to be 1. That's the number you add. Is that clear?
Do you always divide it by 2?
You always divide it by 2.
Okay.
That's why, if you remember, I said I only like to use this method if this number is an even number, a number that you can easily divide by 2, because I don't want to get fractions. I'm going to do another one after we finish this one. I see that this method is still a little bit unclear. So let's finish this up. So when I add 1 to this side, of course, whatever I add to this side, I've got to add to the other side to maintain my balance. This is an equation. You can't do something to one side without doing the exact same thing to the other side. And when you get this x squared plus 2x plus 1, That is a perfect square binomial. That is x plus 1 squared. If you did x plus 1 times x plus 1, you would get x squared plus 2x plus 1. So you have this binomial squared. And on the other side, you have negative 5 plus 1, which is negative 4. And now, since you have something squared equal a number, you can use what we call the square root method. You're going to take the square root of both sides. So the square root of x plus 1 squared is obviously just the x plus 1. You square something and then you take its square root, you're back to stage 1. So on this side, you're getting x plus 1. On the other side, you actually have to do the square root. You have to do plus or minus the square root of that number, which in this case is negative 4. Now, at this point, you can simplify the radical if it's not a perfect square. If it is a perfect square, you could just simplify your radical as much as you can. Now, what can we do with the square root of negative 4? Well, we know that the square root of negative 4 is actually the square root of 4 times the square root of negative 1. Once we see that there's a negative inside our radical, we know that we're going to have to get an answer with an I. It's called a complex root, an I. The square root of 4 is 2. The square root of negative 1 is I. So replacing this by 2i, I get x plus 1 equals plus or minus. Now this is my 2i. I never leave a square root with a negative in the side. If I see a negative inside my square root, I've got to go to I. Now, if the question says, what are the real roots? You would say there are no real roots. There are only, and once you have a square root of a negative number, it's only what we call imaginary or complex roots. And of course, we don't want to find what x, we want to find what x is, so I have to bring this 1 to the other side. So I'm going to subtract 1 from both sides. When I do that, I always take the number that I'm bringing over and put it in the front. So this is negative 1 plus or minus 2i. And you could leave your answer like this because these are not like terms. You can't combine them. What you could do is, if you wanted to, instead of writing it with this symbol plus over minus, you could write it separately as two separate answers, negative 1 plus 2i for one answer, and negative 1 minus 2i for your other answer. So either this answer or write it separately. Now, this is just a more convenient way to do it, especially if you're typing, where if you have this symbol that you have, you don't have to keep, you type less, but it's really very, they both mean exactly the same thing, and they're both considered completely right answers. One thing you might notice also, if you look at the two answers, negative 1 plus 2i and negative 1 minus 2i, is your two answers happen to be conjugates of each other. They're the identical answers, except one has a plus and one has a minus. That's just something that's interesting to note. Is it clear now? Who was it? Who asked me about the complex root? Was it Jennifer? I don't remember.
Yeah, I came in and asked you about it.
Who was that?
That Jennifer.
It was Jennifer. Okay. Did that explain a little bit more?
Yeah, but I would have to need another example. But you could do it at the end of class. If you don't have to do it right now, you can continue with
No,
your.
I want to do another example. Anyhow.
Okay, no problem then.
Okay, so can we erase this and do another problem?
I'm still copying. I'm almost done.
Okay, I'm gonna start taking attendance then while you're doing copying, so then I can put another problem on the board in a minute. Okay, Azia, Azia, you here?
Yes, Professor, yes.
Good morning.
Good morning.
Nashia Allen. Nashia, are you here? Anna Belkis. Emma. Emma, are you here? Emma Benedict. Messiah.
I'm here.
Good morning. Hope you're okay. Corey.
I'm here.
Good morning.
Good morning.
April.
Good morning.
Good morning. Khadija.
Good morning.
Good morning. Umar. Umar, I thought I saw you on the participants. I do see that he's here, and I guess maybe his audio's not working. Yakima. Yakima Ellison. And I see, Emma, that you are here, probably having trouble with your audio as well. Cheryl, I know you're here. Stacia, you're here. Denisha? Denisha here? Devana?
Good morning, Professor.
Good morning. Natalie? Natalie here? Erica?
Good morning, Professor.
Good morning, Erica. Jonathan, I know you're here. Luke? Luke Minot? Luke here? Layla? Layla here? Ashley? Ashley here? I see that you're probably also not. Kachira? Kachira,
I'm here.
good morning.
Good morning.
Jennifer, I know you're here. Rachel, I know you're here. Gloria? Okay. So I hope I can erase this now.
Yes, go ahead.
Okay. And what we're going to do is I'm going to give you one to solve. I'm going to give you time to do it. And I'm going to give you the option to either do it by the completing the square method or by using the formula. I'm going to do, this is going to be one that you can do by completing the square. Let's say I gave you this example. I just made this one up in my head, so I'm not sure if it's gonna be, it may come out to with fractions, but I'm not sure. But the question is x squared minus 6x plus 10 equals 0. Now I'm gonna give you a few minutes to work on this and see if you can do this problem. Again, it is one that you can use for completing the square because this starts out with just a plain x squared. So the a is 1 and the b is an even number. So it could be used, we could use the completing the square method. By the way, I will be posting quiz number 4 on Delta Math probably tomorrow, which will be on chapters 6 and 7, which is on the radicals, the square roots, on the i's, and on the quadratic equations. And I'm going to give you a quiz on Delta Math. I'll again give you, I'll post it, but I'll give you a week to work on it. If anybody has not done or any the quizzes, quiz number 3, or started quiz number 3, or any other of the quizzes and was not happy with their mark, I will reset it for you if you just let me know, and I'll give you an extension on the time. But I'm going to be giving you another quiz so that we will stay current, so that we know we're coming up to the final with having had enough quizzes. The quiz after this one's going to be on Delta Math, but the quiz after this, after we finish the next chapter, which we're going to be starting today, after we finish that chapter, I am going to give you a review quiz on Blackboard. I would say at least one more quiz on Blackboard, possibly 2. I should call the tests on Delta Math are quizzes, and the tests on Blackboards are tests. Again, I just want you to keep knowing how to do those tests on Blackboard so that when it comes to the final, you won't have any problem. I know you've done a couple of them, but it's good to keep doing that. So we're going to have, our next test is on Delta Math. Again, keep looking. I see a lot of people are keeping current with the homework, but don't let that homework get behind, because part of your final grade is homework, participation. Just being part of the class is 15% of your class. The homework and the participation together is 15% of your final grade. And that 15% could really make the difference between a C and a B, or between a B and an A. So make sure you get all those 15 points so that you can maximize your grade for the term. Okay, I think we should start this together. The first thing we want to do, if we're going to do it by completing the square, is to get rid of the 10, because we want only the x terms on the left side. On the right side, we want the numbers. So I'm going to bring the 10 to the other side. So this will give me x squared minus 6x equals negative 10. And now I'm going to use my completing the square by taking half of the number in front of the x. This is the b, the number that's in front of the x. Half of that number is negative 3. What I do with that number is I square it. I multiply it by itself. So negative 3 times negative 3 becomes plus 9. Okay, half of this number squared. Whatever I add to this side, I add to the other side as well. So I have added 9 to both sides of this equation so that this, what was originally a binomial, becomes a perfect square trinomial. This is, in factored form, x minus 3 squared. So whatever, that's why it's so important. You take this number divided by 2. You always divide it by 2. You always take half of it. And that'll give you the number that goes inside the parentheses. And the number that goes at the end is always that number times itself. It's always that number squared. If you would actually have done the factoring on x squared minus 6x plus 9, what you would have gotten is x minus 3 times x minus 3. We're just following the pattern. On the other side, I have negative 10 plus 9, which gives me negative 1. And now I take the square root of both sides. So the square root of x minus 3 squared is x minus 3. And this becomes plus or minus the square root of negative 1. And again, this number has a negative in it. It means it's going to be an I. As a matter of fact, the square root of negative 1 is I. So therefore, we get x minus 3 equals plus or minus I. Remember, square root of negative 1 is not a real number. It's the imaginary number or the complex number, whatever you want to call it, I. I squared is negative 1, but I is an imaginary number. I want to bring the 3 to the other side so that my final answer becomes x equals 3 plus or minus I. And again, you could write it separately as 3 plus I and 3 minus I. Okay, thank you, Devana. Looks like, yeah, it's an I, not a 1. Good, excellent.
Professor, so it's the answer is x equals 3 plus minus I.
Right.
Okay.
And again, if you want to, you could write it separately as 3 plus I for one answer and 3 minus I as your other answer. Notice they are, as I mentioned before, conjugates of each other. I will use this symbol, but again, if you're typing it out, sometimes you can't find this symbol. Though if you're in a Word document, all you have to do is go into the symbols where it says insert. Go to insert and put in symbol, and you will definitely find this symbol. Okay, let's do one more quadratic equation, one that we can't factor, and one that would not be good to use the completing the square. But let's do another one. Can I erase this? Anybody still need this? Okay. It's 5t squared minus 7t equals 1. And if I look at this, I see it's definitely a quadratic equation because it has a square. And it's not one that I would use the completing the square method, because in front of the t squared, it's not just a plain t squared. The leading coefficient here is 5. So I'm not going to use the completing the square method. I'm going to bring the 1 to the other side. And this will give me 5t squared minus 7t minus 1 equals 0. Remember, the only time I don't get it equal to 0 is if I'm going to be using the completing the square method. And I cannot use, there are two reasons. This is not a 1, it's not just a plain t squared, and the number in front of the t is not even. So if I tried to use completing the square, I would run into such difficult fractions. I certainly don't want to do this. And I don't want to use the, I can't use factoring because my AC is t 5 times negative 1. AC would give me negative 5. So I would be looking for two numbers that multiply to negative 5. And when I subtract them, should give me 7. There aren't any regular numbers, because the only thing that I know that multiplies to 5 are 1 and 5. And when you subtract them, you get 4, you don't get 7. So our only choice in this case is to use the quadratic formula. Okay, I'm stopping right here. I'm giving you a few minutes to do this problem using the quadratic formula. I'm going to, it's a multiple choice question. So on the side over here, I'm going to give you the possible answers, and you're going to pick out the correct answer. Again, choice A is 7 plus or minus radical 69 over 10. Choice B is 7 over 10 plus or minus radical 69 over 10 I. C is negative 7 plus or minus the square root of 69 all over 10. And D is negative 7 over 10 plus or minus square root of 69 over 10 with an I. So there are two that have I's and two that don't. Okay, let's do a couple more. Give you a couple of minutes for that.
Professor, I got a question.
Yeah, sure, I'm listening.
Does A count for two answers?
A is 7 plus or minus radical 69 over 10. So that's two answers. One is,
Okay,
that plus or minus always means two answers.
okay, thank you.
Okay, I see some people already have the answer, so I think we should work on it. As I said, I'm going to use the formula, which is negative b plus or minus the square root of b squared minus 4ac, that whole thing over 2a.
Professor, I'm sorry. Layla is stuck in the waiting room. She needs to be let in.
Oh, okay. I can't even let her in because
She's good.
uh, Melissa, you did it? Okay, great. Thanks. Okay, I'm marking her here. Okay, I got. Okay, so let's see what the A, the B, and the C are. The A is the number in front of the square term, so that's 5. The B is the number that's in front of the X term, which is -7. And the C is the standalone number, which is -1. Remember, that's why you have to get it equal to 0, so you can figure out what the A, the B, and the C is. So if I stick in these numbers, I'm going to have negative, that's my B is -7, plus or minus the square root of -7 squared. Notice I'm putting all of these numbers in parentheses in place of the letters, minus 4 times A, which is 5, times C, which is -1, all over 2 times 5. And I can't talk now. The big thing is to simplify what's inside the radical. So let's do that first, and then I'll simplify. -7 times -7 is +49. And then we have -4 times 5 is -20. And -20 times -1 is +20. So this comes out to be the negative and the negative become +7 plus or minus the square root of 69, and it's all over 10. There's nothing to do with the 69. It can't even be simplified. And if you realize, yes, people did get choice A. Choice A is the correct one. Notice I right away, when I saw the number inside the radical was a positive number, it was 69, I knew it couldn't have any I. The I could only come from a square root with a negative. The whole thing would have been negative. Don't forget, when you're squaring a negative number, it becomes positive. -7 times -7 is +49, and -4 times 5 times -1 is +20. That's how you get that 69, and it's choice A. Any question about that? Okay. I see whoever did, everybody sent in the right answer that sent it in. So, and as I said, these examples I'm taking are examples that are off of old finals. So therefore you see that if you can do these, you really are prepared. Remember, you must know that quadratic formula. They're not going to give you the formula. You must know it by heart. And don't make a mistake. I've seen people who make a mistake and write B instead of -B. You must know the formula. You must write it down and memorize it, because it's the most important formula that you're going to learn this whole term. Okay, now, Okay, so I'm going to, so we really completed chapter 7 now. We're going to be starting chapter 9. I'm skipping chapter 8. Chapter 8 is going to be the last chapter. For some reason, that's how the syllabus is written, and I may as well follow it the way the syllabus is written. We're going on to chapter 9. The title of chapter 9, let me just erase this so we can start fresh. The title to chapter 9 is called Conic Sections. And what we study in conic sections is graphing again. Let's think of how we started this term. We started this term as with a review of doing regular, what we called linear equations, equations that didn't have any exponents. And after we finished linear equations, then we went into graphing. And we graphed linear equations. And we saw the reason they were called linear equations is because I could put it in what we call the y equals mx plus b form and get the equation. And when I drew it, I got a line. We did a bunch of other things in the interim. And then we started talking about quadratic equations. And really now we're at the point where we could take any quadratic equation, any equation that has an exponent of 2 in it, and we can solve it. So now we're going to talk about what does the graph of a quadratic equation look like? What does the graph of an equation that has an x squared or a y squared in it look like? It can't be a line because a linear equation doesn't have any exponents. So what shapes do we get when we have an equation that has either an x squared or a y squared or both in it? And it turns out that there are 4 basic shapes that you can get. What are those 4 shapes? One is called a circle. These are all, this is going to sound familiar. Of course, you know what a circle looks like. A circle has a point in the middle called the center, and then it's all around it the same distance all around it. The length of from the center to the edge of the circle is called the radius. But basically, a circle is something like your tire. That's a circle. Hopefully it's a circle, because if it's not a perfect circle, you're not getting your best mileage or doing too well. But that's what, actually, if you think about the Earth itself is not a perfect circle. It happens to be a flattened circle. The next type of flattened circle, that's what the Earth is. So it's not a perfect circle, but a perfect circle is the same all around. So that's one of the shapes we can get when we have a quadratic equation. Another shape we can get is something called an ellipse. An ellipse is basically a flattened out circle. The orbit of the Earth around the sun is not a perfect circle. It's a flattened out circle. That's what we call an ellipse. Another word for ellipse sometimes is oval, a football. I mean, though it's not so pointy at the end, football is pretty pointy at the end. But if you took, or you had a balloon and a round balloon and you pushed it in, you'd get an ellipse. Another shape that you get is something called a hyperbola. This is the strangest name and the strangest shape. The only thing that's good about it is that you don't have to know too much about it. A hyperbola is where you have two separate pieces facing away from each other. It's like you took your ellipse or your circle, you split it in half and turned it inside out. Then, except these keep going on and on and on. It's a very strange shape. That's a hyperbola. And the fourth shape is something called a parabola. Now, a parabola, if you notice, a hyperbola looks like it's a U-shape one way and a U-shape back to it. And sometimes the hyperbola, these U's are, as I said, back to back. They might be sideways, or sometimes you could even have them one up and one down, but they're two U's. A parabola is just a single U. Something like this. These four shapes, circle, ellipse, hyperbola, and parabola, are what we call the conic sections. They are the shapes that you get when you have a quadratic equation and you try to graph that quadratic equation. It turns out in the first three, you're going to have both x squared and y squared terms. It's going to be quadratic in both the x and the y, x squared and y squared. The parabola only has an x squared and not a y squared. So that's why I put it fourth. But as you notice, they all have exponents of 2. They all have squares. Why are they called conic sections? I'm just going to tell you why it's used, but you don't have to know it. What you have to know is what I just told you. What are the conic sections? Circle, ellipse, hyperbola, parabola. I've even seen a question where it says, which one of these is not a conic section? And it'll say circle, hyperbola, parabola, rectangle. And you know the one that's not a conic section is a rectangle. So you have to know what are the four shapes that make up the conic sections. If you think about the word conic, conic comes from the word cone. Think about an ice cream cone, and I'm trying to draw a picture of an ice cream cone. Now this is supposed to be a three-dimensional thing. So picture your ice cream cone. Look down at you're holding the ice cream cone in your hand and you're looking down in it. Notice it doesn't have any ice cream in it. What's the shape you're going to get? It's going to be a circle. The edge of the cone makes a circle. Now, what if I took my cone and I sliced it like this? Notice it wouldn't be a perfect circle anymore. What you would have is a sort of squeezed in circle or an ellipse. What if I went straight down like this? Notice what I would get would be a U shape, a parabola. And if I had one cone right on top of the other, and I continued, I'd have one U going up and one U going down like this. And you would have your hyperbola. So all of these shapes you can get by slicing or sectioning. That's what sectioning means. When a doctor goes into the operating room and he does a section, what he's doing, like a cesarean section, is he's cutting. He's cut. So we're cutting our cones in different angles and we're getting one of these four shapes. That's why it's called conic sections. And you don't have, that's not something that's important to know. It was just that, why would they use the word conic? But what we're going to do is look, what do we have to know? Aside from having to know what a conic section is, we have to be able to look at the equation, a quadratic equation. If I would give it to you, I want to look at it and tell what the shape is and what is the important features. And I'm going to start with the circle because the circle is quite easy. I think when I start with the circle, well, then I guess I'll do it in the order I wrote it down. Okay, so I'm going to erase these. And we're going to start with the first one that we. So let's talk about a circle. Now, the easiest equation, this most basic equation of a circle looks like this: x squared plus y squared equals some number, we're calling it r squared. In other words, for example, I might have x squared plus y squared equals 25. This would be an example of an equation of the circle. Notice what the equation consists of. It has an x squared term and a y squared term. The number in front of the x squared and the number in front of the y squared both happen to be 1. Sometimes you'll see a circle where they'll both be 2s or 3s, but basically it's usually 1. Whatever it is, these two numbers have to be exactly the same. And on top of that, not only do they have to be exactly the same, the sign in between them has to be plus. If you have that situation, the number on the other side, which in this case is 25, is what we call the r squared. Now the r stands for, we know what a circle needs. It needs to have a center and it has to have a radius. The radius of this circle is this, if you square it, will give you 25. So obviously if the radius squared is 25, your radius has to be 5. And notice I'm not saying it could be plus or minus 5 because we're talking about how long the line is. It can't be negative. The radius of the circle is 5. And the center of this circle is the origin. So whenever you have something like x squared plus y squared, no other x squared terms, no other y terms, just one plain x squared, one plain y squared equaling a number. The number on that other side, if you take its square root, will give you the radius. And the center of that circle will be the origin. If I wanted to graph this, here's what it would look like. Here's my piece of graph paper. My center of my circle is the origin. The radius is 5. That means I'm going to count 5 in every direction. 1, 2, 3, 4, 5 to the right. 1, 2, 3, 4, 5 up. 1, 2, 3, 4, 5 to the left. 1, 2, 3, 4, 5 down. And if I connect these, of course I don't make it's straight lines, it's curvy, I will get a circle. I know it looks a little bit off. That's why, obviously, if you would do it on a graph in a, let's say on Delta Math, it'll probably come out to be a perfect circle. I don't know if I don't even think this topic is covered in Delta Math. But basically, the simplest circle is the circle whose center is at the origin. And then its equation is x squared plus y squared equals r squared. Notice I gave you the equation and drew the circle. I could have done the opposite. I could have drawn the circle and asked you to, what is the equation? So let's say I gave you this circle. Let me move this up. Okay, this was a circle. The center, I'm just putting it, is 0, 0, and the radius was 5. That was point A. I'm drawing a picture now. Does anybody want to tell me what they think the equation of this circle is going to be?
Three.
Okay, because you said 3. What's 3?
The radius.
The radius of the circle is obviously 3.
But the radius squared would be 9.
So r squared is 9. Perfect. So what is the equation going to look like?
0, 0.
No, remember what the equation has to start out with.
Oh, it'll be 3 squared plus 3 squared equals 9.
No, your equation has to have the x and the y, and it's x squared. You leave the x squared and the y squared there. It's x squared plus y squared equals 9. Just like when you write the equation of a line, y equals mx plus b, you always leave the x and the y in the equation. You just put in different numbers. The same thing with the equation of the circle. You have to keep the x squared and the y squared. The only thing that you replace is this r. In this case, the r was 3 because the radius of the circle was 3. So therefore, the r squared is 9. So the equation of this circle is x squared plus y squared equals 9. Again, when I see an x squared plus a y squared equal a number, it'll tell me I have a circle, and the radius of that circle is whatever the square root of this number is. Are we okay with this? Any questions about this? Okay. So can I erase this? I want to go a little step further. What if we have a circle and the center is not at the origin? The standard equation for for a circle who's not at the origin looks like this. X minus a squared plus y minus b squared equals r squared. In other words, it's gonna be a little bit more complicated. We're not just gonna have a plain x squared and a y squared. we're going to have the x together with something in a binomial squared and the y together with something in as a binomial squared equals r squared. For example, I might have something like this. X minus 2 squared plus y minus 3 squared equals 16. Now, I am going to recognize that this is a circle. It has an x squared, it has a y squared equaling a number squared. But there are these two extra numbers in here. There's x minus 2 squared, there's y minus 3 squared. Those extra numbers, the a and the b, give us the center of the circle. So if I look at this equation, I can tell you right away that the center of this equation is 2, 3, because I take, notice this was an x minus 2. I switched its sign because this said x minus a and the center is a. Whatever number is over here, I have to switch its sign, so it becomes a 2. Again, over here, that gives me the x of the center. The number with the y gives me the y of the center. Again, I switched its sign. So the center of this circle is the point 2, 3. This number over here is my r squared. My r squared was 16. So that means the radius has to be the square root of 16, which is 4.
I have a question. I'm sorry. So for example, it says x minus 2 squared plus y minus 3 squared. So the center will always be the reciprocal? That's what I'm getting. Maybe I'm
Not
wrong.
reciprocal, opposite sign.
Opposite sign. Okay.
Reciprocal means to flip it over. I'm not flipping it over, I'm just switching its sign. And yes, I always switch the sign. I'm going to show you that if I had a plus there, I'd have to make it minus.
Okay.
Okay, but let's draw this. Let me show you what this would look like. Again, I will recognize this. How did I recognize it was a circle? Because if I looked at it without any of the extra numbers, I saw that I had an x squared plus a y squared. The x squared plus the y squared tells me I have a circle. The circle center is, in this case, 2, 3. So that means I go 2 to the right and 3 up. So here's my center, my circle. Now remember, this is graph paper, right? Here's my graph paper. These are my graphing lines, or some of them. Here's a piece of graph paper, right? Here's the center of my circle. From the center, since my radius is 4, I have to go 4 in every direction. That means I have to go 4 up. 1, 2, 3, 4. From the center, 4 to the right. 1, 2, 3, 4. 4 to the left. 1, 2, 3, 4. I didn't put in all the lines. And 4 down. 1, 2, 3, 4. And if I connect these points, there's my circle. Instead of starting at the origin, I'm now starting at the point 2, 3. So that's what a circle looks like. So either my circle is going to have its center at the origin, or its center is going to be someplace else on the piece of graph paper. And I'll know what that center is by looking at the numbers that are in the parentheses with the x and the y. Don't forget, since this was x minus 2, my x center was positive 2. Since this was y minus 3, my y center was positive 3. So I went to that point 2, 3. Again, you'd need a piece of graph paper because from that point is where you want to count the radius in all
Professor,
directions.
excuse me,
Yes.
Claus is trying to get in.
Who?
Claus.
I'm sorry, what, I didn't hear what you said.
What's that?
Is yeah,
Is there
There's-
trying to get in?
yeah.
There's nothing.
No, is there's
I'm in. Thank you.
Okay.
all right.
Oh,
Okay. I don't know what's going on because I let Melissa take care of it and she does a great job. I'm so glad I don't have to do it.
yeah,
Okay.
it takes a while for it to pop up. So it's just like, but I don't see anybody in the waiting room.
All right, I think she got in now. You know, and she was in before. That's what happens. Sometimes you get just knocked out and then you have to start this whole process again. I would love to dispense with the waiting room. How many people thinks we should do that? Should we try without the waiting room? We haven't had any problems. No opinions?
Yeah, I think you could do the without the rating room already because I think everybody's mature enough to know that you shouldn't be giving up stuff.
Okay, look, I think for tomorrow, let's try without the waiting room. And we'll do it, if we run into problems again, we can always go back to the waiting room. Okay? I'm just gonna have to remind
You
myself.
wanna quit? Don't do the waiting room again?
I think I'm going to, I think, because it, hopefully everybody, I don't think that, we haven't, Melissa, we haven't been having any problem.
That's the whole point. Like I don't know. The waiting room is fine for me. Like
I know, but it's, it just, it's a little bit of a pain. This way people could just come in and out, you know, like if they get knocked off, they don't have to wait again. So let's try it without a waiting room. Let's see if it works. If it doesn't work, we'll go right back to the waiting room. Okay? I'll see if I can, I hope I'll know how to set it up. Once it has a waiting room, I have to go back to the settings and see what I can do. Okay, so if you still see the waiting room, then you're gonna have to wait. If not, we may be able to get right in, okay? So let's go back to another example. Let's say I had the example x plus 1 squared plus y minus 2 squared equals 9. And I want to draw this equation. Now I know it's a quadratic equation. I see those squares. And on top of that, if I ignore the numbers inside the parentheses, basically what I have is an x squared plus a y squared. I know it has to be a circle. And on top of that, I know that the radius of the circle has to be 3 because this number over here is 9. I take that square root. That is my r squared is 9. My radius is 3. But what is my center? The center I get by looking at the numbers that are inside the parentheses. In this parentheses, I see a plus 1. With the x, there's a plus 1. So the x of the center is -1. In this parentheses with the y, I see a -2. So this y center is +2. I change the sign. I don't take the reciprocal, I change the sign. If it's positive, I make it negative. If it's negative, I make it positive. So I know totally what this circle is going to look like. It's a circle with a radius of 3 and a center that's the point -1, 2. if all I'm asked is what is the center and what is the radius, well, I have it. The center is -1, 2. The radius is 3. If I want to draw it, well, let's see how we're going to draw it. I first locate the center, which is the point -1, +2. And then I count 3 in every direction from this center. So here to the right, 1, 2, 3. Up, 1, 2, 3. Again, if you have graph paper, you'll see it much clearer. To the left, 1, 2, 3. Down, 1, 2, 3. And I connect these 4 points with a circle. Here's my circle. Again, with the center at the point -1, 2. Okay? So this is the standard form of a circle. X minus a squared plus y minus b squared equals r squared. Let's say I give you, I'm going to go backwards. Suppose I tell you that I have the center of my circle. This is a different example. This is example. This was example 1. This is example 2. In example 2, the center of my circle is 4, -5. Okay, can everybody see that that's a -5? Let me rewrite this. Okay, that's the center of my circle. The radius of my circle is 2. See if you can write the equation of this circle. Over here, I gave you the equation and I asked you what's the center and the radius. Now we're going backwards. I'm telling you what the center and what the radius is. I want you to write the equation of the circle. I'm going to give you a minute to think about this. Cheryl, are you clear on how I got things now?
No, Professor.
Okay,
But,
I'm going to go back to this. Well,
okay then. Okay, thanks.
look at this equation, right?
Mm-hmm.
You see there's a number next to the x?
Yes.
Switch its sign. What do you get?
-1.
Right.
Mhm.
That's the x of the center. You see this number
Okay. Yes.
next to the y?
Yes.
Switch its sign. What do we get?
+2.
That's the y of the center.
Okay.
So I get to the center, this a and this b. The numbers that are in the parentheses next to the x and next to the y give me the center.
Okay then.
Is that clearer?
Yes, thanks.
Okay, let's look at this problem now. Remember, my standard equation for a circle is x minus a squared plus y minus b squared equals r squared. That's the sense, what we're looking for when we're trying to write the equation. It's a lot more complicated than y equals mx plus b. It's because it's got squares in it. But I know what to put in. In place of the a, I have to put the 4. In place of the b, I have to put the -5. And in place of the r, I have to put the 2. Because that's what this tells me. The a is the x of the center. The b is the y of the center. And the r is the radius. So if I do this, this is what I get. X minus 4 squared plus y minus -5. Notice there are two negatives here. A minus a -5, which becomes a +5. And that equals r squared. Remember the r is 2, so r squared is 4. The equation of the circle whose center is 4, -5, and whose radius is 2 is x minus 4 squared plus y squared, 5 squared equals 4. Notice these numbers get their signs switched. This was a +4, so in the parentheses, it's -4. This was a -5, so in the parentheses, it's a +5. And the number on the other side is the radius squared. So I can go both ways. I can take the equation of that they give me of the circle and figure out what the center is and what the radius is, or vice versa. I can tell what the center and the radius is and figure out what the equation is. Okay, now I want to go one step further. To the type of a question that you will invariably see on a final. This is equation. Let me see if I can get one off a final. Here's an equation. It says, find the center and radius of the circle x squared plus y squared minus 8x plus 14y equals -61. Now they're telling me this is a circle. And it seems to make sense because I see an x squared and I see a y squared. But there's this extra stuff over here. It's not set up like this one. It's not in the factored form. I can't see what the center and the radius of the circle is. Again, when I see x squared plus y squared, it does mean circle to me. But there has to be something else going on here. I have to get it from this form, which is the totally expanded form, into what we call the standard form. How are we going to put it back into this format? And I'm going to show you, I'll call it a little trick, but a trick that you know most of the steps for already. Here's what you do. We're first going to rearrange things. We're going to put all the x terms together. So I'm going to do the x squared, and the other x term is -8x. And I'm going to leave a space. Then I'm going to get the y terms. So the next thing I have is a y squared and a 14y. And again, I'm going to leave a space. And any number that doesn't have either an x or a y in it is going on the other side, which it already is. So collect the x's together, collect the y's together, plain numbers, no x or y on the other side. And what we're going to do is we're going to complete the square on both the x's and the y's. And that's why I wanted to do this right now, because we just talked about completing the square. Now we know how to complete the square. First of all, it has to be a plain x squared, which it is. Then what we do is we divide the number in front of the x by 2. That'll give us -4. And what we do with that -4 is we multiply it by itself. We square it. It's called completing the square. We square -4, and what we get is +16. So that this x squared minus 8x plus 16 is now a perfect square. Now, of course, because I added 16 to this side, I've got to add the same exact thing to the other side. Just like we did with the quadratic equations.
Wait, Professor,
Whatever you add to one side, you add to the other side. Yes, question.
where did you get the 16 from?
Again, I take half of this number. How much is that?
4.
4. And I square it. 4 times 4.
Okay.
Half of this number squared. Put it in your notes. Completing the square means take half of the, let's call it the b, and multiply it by itself. Okay. Let's see what happens with the y. We have to do the same exact thing with the y's. What do we have to do? Well, this is again a 1, so that's okay. It has to be because otherwise it wouldn't be a circle. And I take half of this number, so half of 14 is 7. And what do I do with that 7? Which I do with the 7?
You square, right?
You square it. So
Yeah.
7 times 7 gives me 49. So I have to add 49 on this side. So therefore I have to add 49 on this side. Notice I'm trying to do it. Does everybody see that it's different colors? I don't know if it's coming across. I wanted to do different colors so you could see what was where I added to the x and where I added to the y's. Okay, now let's see what we have. This x squared minus 8x was 16. Could then remember, this is a perfect square binomial. That's x minus 4 squared. That's why I like to put that -4 down right away, because I know that's what's going in the parentheses. Then we have the y's. So what do we have with the y's? The y is y plus 7 squared. Again, I put that 7 down because I knew that's what's going to go in that parentheses. This is the square. And on the other side, let's see what we have. We have to add, I'm going to take out my calculator actually for this. I have to combine -61 plus 16 plus 49. And when I add all those numbers together, I get 4. I have taken this expanded version and put it back into the standard version where I have x plus or minus something squared and y plus or minus something squared equaling a number. Because in the standard form, I can now tell you that the center of this circle is, okay, this is a -4, so the x is going to be +4. This is a +7, so the center is going to have, the y is going to be -7. And the radius is going to be the square root of 4, which is 2. So I would say we're now being able to use this method of completing the square another way. We used it not to solve a quadratic equation, but we used it to put the expanded version of the circle, the one that didn't have any parentheses, back into the standard format so I can tell which is the center and which is the radius. Can I do another problem? would like to do another problem and then I want to give you one to try, okay? Okay, so I'm
Yes.
gonna, okay, can I erase this?
1 second.
Okay. Okay? And here's my next problem. Okay. The instructions, I see this x squared plus y squared, but there's extra stuff. It isn't just plain x squared plus y squared, because if there was nothing else except a number there, then I know the center was at the origin. But here I have this x and y, which means I have to get it back to the standard format. So let's remember how we do that. We put all the x terms together. So we have x squared, sorry, minus 4x, and leave us a space. Then we put the y terms together. So we have y squared plus 6y, and leave a space. And then I have this 4 that doesn't have any x or y next to it, so I have to get it to the other side. So that's going to equal -4. So I set it up so I can use completing the square to get it into the standard form. To complete the square on the x, I take the number in front of the x, which in this case is -4, and divide it by 2. That gives me -2. And I multiply the -2 by itself. I square the -2. -2 times -2 is +4. It'll always be a positive number because when I square a number, it always comes out to be positive. Whatever I added on one side, I add to the other side. So that becomes a +4 on the other side as well. And this x squared minus 4x plus 4, I can then write as x minus 4 squared. That's the whole point. We made this, I added the third term to the trinomial so that this became a perfect square and I could write it as a binomial squared. I'm not going to do the same thing to the y's. I take half of the number in front of the y, which is 3, the positive 3, and I multiply by itself. 3 times 3 is 9. So that, and whatever I add on this side, I add the same exact thing to the other side. I've got to maintain my balance. So over here, this y squared plus 6y plus 9 becomes y plus 3 squared. Okay, there's a plus in, there has to be a plus in between these two parentheses. And I add, there are now 3 numbers on the other side. The number I added from completing the x's, and the number I added from completing the y. So -4 plus 4 is 0. 0 plus 9, this whole thing becomes 9. So I now have this in standard format. X minus a squared plus y minus b squared equals r squared. And now I can tell you the center of this circle is the point. This is a -2, so this becomes a +2. This is a +3, so this becomes a -3. The center is the point +2, -3. The radius of the circle is the square root of this number. The square root of 9 is 3. Okay, let's see if I can give you one to try on your own. All right, can I erase this? Okay, so here's your problem. Okay, so it's x squared plus y squared plus 6x minus 4y minus 12 equals 0. This is the equation of a circle because I see this x squared plus y squared, but the center is not at the origin because it has other extra and y terms. Find the center and radius of the circle. Okay, we have just about 5 minutes left, so let's do this together. Remember what I do. I take the x terms and put them together. X squared plus 6x. I take the y terms and put them together. Y squared and minus 4y. And the number that doesn't have an x or a y, which is this negative 12, I have to bring to the other side. So that gives me 12. So first of all, I rearrange things so that I can complete the square. So then I take half of this number, which is plus 3, and square it. 3 times 3 is 9. I add 9 over here, which means I have to add 9 over here. And that gives me that this is x plus 3 squared. Okay, now I take half of this number, which is negative 2, and I square it. Negative 2 times negative 2 is positive 4. I add 4 over here, which means I have to add 4 over here. And this becomes y minus 2 squared. So I've completed the square on the x and on the y. Now I add up all these numbers. 12 plus 9 is 21, plus 4 gives me 25. I've now put the equation back into standard form, which means now I can tell you that the center of my circle is, well, this is a plus 3, so that has to be minus 3. And this is a minus 2, so this has to be a plus 2. And the radius has to be the square root of the 25, which is 5. So if we're asked, what is the center? The center is a point negative 3, 2. The radius is 5. The radius is 5, not 10. The radius is 5. Azia, you're right. You're perfectly right. Okay, does anybody have any questions about this now? All right, so we're going to be continuing with this study of the conic sections tomorrow. We'll review what we did on the circles, and we'll go on to the ellipses and hyperbolas, and then the parabolas we'll probably do on Tuesday. All right, any questions? All right, then everybody have a good day. Melissa, you'll end the recording for me? Melissa? Any question? Melissa, can you end the recording? Okay, thanks, Cheryl. Okay, I'm gonna leave now.
Okay, bye, Professor. Thank you.
Bye-bye.
Melissa?
Yeah.
I wanted was to stay, but I have a seminar to watch, something to write a paper on,
Mm-hmm.
and it had started from 11:30. So because I had wanted to stay on for this topic, but unfortunately, I have to watch that
Alrighty.
thing to write. So I can't stay today. I
Okay.
was hoping to stay, but I have to watch something to write.
Just send me anything on in my email. I'm good.
All right, then. Thanks much.
All right.
Have a blessed day.
All right. Same to you.
Yeah, thanks.